Today we'll be looking at the difference of squares. 9x squared minus 64 is equals to 0, and x squared minus 81 is equals to 0. We'll just quickly remind ourselves of the general form of a quadratic equation. And that's simply ax squared plus bx plus c is equals to 0, provided a is not equals to 0. So the ax squared term must be there for this to be a quadratic equation. So in a quadratic equation, the highest power of the variable, in this particular case, x, is 2. So the power of x is 2, and that power is actually what makes it a quadratic equation. So a is the coefficient of x squared, b is the coefficient of x, and c is a constant. The constant can be, it could be a negative number, it could be a positive number. So look at the quadratic equation again to establish one or two things. So we said ax squared plus bx plus c is equals to 0, where a is not equals to 0. We have explained that if a is 0, then we are left with bx plus c is equals to 0, and that becomes a linear equation, because then bx plus c, the power of x becomes 1, and that becomes a linear equation. So for a quadratic equation to remain, a must not be equal to 0. So we want to see various scenarios when b is 0, or where b is 0, the middle term disappears, and then we're left with as squared plus c is equals to 0. At this point, do we still have a quadratic equation? Yes, we do, because the power of the variable there, x in this particular case, is t raised to power 2. So we have a variable that has a power of 2, therefore we still have a quadratic equation. So examples of this include s squared minus 4 is equals to 0. Our questions that we're going to solve today, both of them fall into this particular category, where ax squared plus c is equals to 0. Like I said before, your c can be positive or negative. So we'll be looking at other scenarios. In this particular scenario, we'll be looking at a scenario where our c, or constant, is 0. That means the third term will disappear, and then we're left with ax squared plus bx is equals to 0. And an example is as shown below, 5x squared plus 6x is 0. Is this a quadratic equation? Yes, it is. The only difference is that c term is now equals to 0. So once again, we'll be looking at the quadratic equation. This time around, we'll be looking at other scenarios where b is equals to 0, and also where c is equals to 0. So that knocks off both the second and the third term. We have examples here where we only have the first term after the second and third term have been knocked off, and the examples include 6x squared is equals to 0 and minus 2x squared is equals to 0. So is this still a quadratic equation? Yes, because the first term, which is ax squared, still has the power of 2, and the quadratic equation has its highest power of 2. Now, we've been doing all this preamble just to have a kind of recap of what quadratic equations are, so that we can now commence solutions to our current problem. So we'll be looking at the difference of squares, which can be expressed mathematically. A squared minus b squared is equals to a minus b into a plus b. A squared minus b squared is what you call the difference of squares. A squared, of course, is a square. B squared is a square. So when you have a square subtracted from another square, it is simply factorized as depicted. So a squared minus b squared will be a minus b into a plus b. Now when you have 9x squared, you can write it as 3x into a bracket all squared, because if you expand it further, it now becomes 3x times 3x, and that becomes 3 times 3, which is 9, and then x times x, which is x squared. So 3x all squared is equals to 9x squared. Similarly, we can write 64 as 8 squared, because 8 times 8 is 64. So what we have is 9x squared minus 64. It can be rewritten as 3x all squared minus 8 squared. And if we look at 3x all squared minus 8 squared, it is an example of a difference of squares. It is an example of what? Difference of squares. So that means the above rule, a squared minus b squared, is equals to a minus b into a plus b applies. In this particular case, what we will have is 3x minus 8 into the brackets. We will now have 3x plus 8 bracket close. We will have what? 3x minus 8 into 3x plus 8. Let's see how it goes. So we're dealing with difference of squares, which is very, very easy. So we have written, so this is the question actually. The starting point is 9x squared minus 64 is equals to 0. We have broken down 9x squared minus 64 is equals to 0. It's now represented as 3x all squared minus 8 squared is equals to 0. What we are trying to express it as in the difference of squares, so that we can apply the difference of squares rule. So we now have 3x minus 8 into 3x plus 8. And then when you have two terms multiplied to equals to 0, what this tells you is that either A is 0 or B is 0. So we'll simplify. So we have 3x minus 8 into 3x plus 8 is equals to 0. That tells you and me that 3x minus 8 is equals to 0, or 3x plus 8 will be equals to 0. So let's start with the left hand side. So 3x minus 8 is equals to 0. What we'll simply do is to take group the like terms. So we take the minus 8 to the right hand side. It will now become positive 8. And then 3x is equals to 8. We divide both sides by 3 so that we can solve for x. So x will now be 8 divided by 3. Because when you divide the left hand side by 3, the 3 cancels out, you're left with x. And then when you divide the right hand side 8 by 3, so you have 8 over 3. Let's solve for the other x on the right hand side. So you have 3x plus 8 is equals to 0. When you take the 8 to the right hand side, you have 3x is equals to minus 8. And then when you divide both sides by 3 so that you can solve for x, you have x is equals to minus 8 over 3. So we have two solutions for x. X is equals to 8 over 3, or x is equals to minus 8 over 3. So we'll go to the second question, and we'll just do a recap, knowing fully well that the difference of squares a squared minus b squared is equals to a minus b into a plus b. So our question is x squared minus 81 is equals to 0. That was the problem we have, or we had. X squared minus 81 is equals to 0. But before we solve that, let's rewrite x squared minus 81 as a difference of squares. So we know that 81 is 9 squared, so we'll say x squared minus 81 is equals to x squared minus 9 squared. So that means we can now apply the difference of squares above, which says that when you have squares subtracting each other, a squared minus b squared will be a minus b into a plus b. So x squared minus 9 squared will be x minus 9 into x plus 9. So our initial question, x squared minus 81 is equals to 0, can simply be written as x squared minus 9 squared is equals to 0, which is difference of squares, and therefore we can apply the difference of square formula. A squared minus b squared is equals to a minus b into a plus b. What's our a here? Our a is x. What's our b? Our b is 9. So it becomes x minus 9 into x plus 9 is equals to 0. And when you have a product that is equals to 0, ab is equals to 0 means a times b is equals to 0. It tells you that either a is 0 or b is 0. So in this particular case, we have x minus 9 into x plus 9 is equals to 0. So that means x minus 9 is equals to 0, or x plus 9 is equals to 0. So we'll solve them one by one. Let's look at the left hand side. X minus 9 is equals to 0. That tells you that when you take the minus 9 to the right hand side, it now becomes plus 9. So our x is equals to 9. Let's solve for x on the right hand side. We have x plus 9 is equals to 0. When we take the 9 to the right hand side, it becomes positive 9 now becomes negative 9. So we have x is equals to minus 9. So that is the solution for the difference of squares. So our x is 9, or x is minus 9 for this particular question. So we'll see the summary from the two questions, the first one being 9x squared minus 64 is equals to 0. Our solutions are x is equals to 8 over 3, or x is equals to minus 8 over 3. And then for the second question, which is x squared minus 81, which is equal to 0, our x is either 9 or our x is minus 9. So I believe that's very clear. Thank you.